Hello students, today we are going to discuss scalar product and its properties. So first of all, we will see what is scalar product. Scalar product is also known as dot product. Consider these two vectors, vector A and vector B, and suppose theta is the angle between them. Therefore, the dot or scalar product between this vector A and B is given by vector A dot vector B is equal to the magnitude of A, magnitude of B, and cosine of angle between them, that is AB cos theta. So the standard definition is the scalar product of two vectors, that is vector A and B, is defined as the scalar quantity which is equal to the product of the magnitudes of given two vectors and cosine of angle between them. Now we will move towards the properties of scalar product. So we'll see first, when two vectors, that is vector A and B, are mutually perpendicular to each other, their scalar or dot product is 0. Okay, consider two vectors, vector A and B, and suppose they are perpendicular to the each other and the angle theta between them is 90 degree. So suppose these are the two vectors, vector A and B, and the angle between them is 90 degree. So by the definition, what is vector A dot B is equal to AB cos theta, and theta is 90 degree, and we know that the cos 90 is nothing but the 0. So AB, the magnitude of the vectors A and B, into 0, that is 0. It means that the scalar product and the dot product is 0. When the angle between those vectors is 90, the scalar product is 0. So therefore, when two vectors are mutually perpendicular to each other, their dot product is 0. This is the first property. Now we will move towards the second property. Suppose the vectors are collinear. Collinear vectors means the vectors along the same line. We have already studied in our last lecture. The collinear vectors means they are along the same line and the angle between them is 0 or 180. Okay, we will consider first case. When the angle between them is 0, it means that when the vectors are in the same direction or parallel. Suppose these are the two vectors, vector A and vector B. We have represented by the green and yellow color, and suppose those vectors are parallel vectors, or in same case we can consider those two vectors, vector A and B, along the same line, okay, in same direction. It means the angle between them is 0. So according to the definition, angle between them is 0 means theta is equal to 0 degree. So according to the definition, we will know that A dot B is equal to AB cos theta, and here the angle between them is 0. It means cos theta 0, and cos theta, it means theta is 0. So cos 0 is nothing but the 1. By putting into that formula vector A dot B, it means AB cos theta, cos 0 is 1. So A dot B is positive. It means scalar or dot product of like or parallel vectors, okay, is positive. Now we'll consider second case in same property. Okay, case number 2, when vectors are opposite direction or anti-parallel, it means suppose these vectors A and B are anti-parallel, it means the angle between them is 180 degree, that is pi. And suppose these A and B are along the same line but in opposite direction, so the angle between them is 180 degree, and we know that the cos pi, theta is pi, and cos pi is minus 1. Cos theta, it means cos pi is minus 1, here theta is pi. So according to the definition of dot product, vector A dot vector B is equal to AB cos theta, and in place of theta there is pi. So cos pi is minus 1. So it means that vector A dot vector B is nothing but minus AB. The output is negative. So it means that scalar or dot product, when the vectors are in opposite direction or anti-parallel, the scalar or dot product of those opposite or anti-parallel vectors is negative. So this is second property. Now we will move towards the third property. If we consider two equal vectors, so the dot product in between them or scalar product in between the equal vectors is nothing but the equal to the square of its magnitude. So we will prove it by mathematically. Suppose two vectors A and B are equal vectors. The equal vectors means A equal to B. So vector A dot vector B is nothing but vector A dot vector A, because both the vectors are equal. When they are equal vectors, the angle between them is 0. So according to the definition, AA cos theta, two vectors are equal, that's why we can write a equal to b, that is a cos theta, and angle between them is 0, so cos 0 is 1, so a into a is a square. So the product will be a square, so it means the scalar product of two vectors is a square, square of its magnitude. Similarly, if we see the unit vectors I dot I, that is magnitude of I square, that is 1, j dot j, similarly k dot k is 1. So third property is the scalar product or dot product of two equal vectors is equal to the square of its magnitude. Now we will move towards the fourth property. Fourth property is scalar product or dot product is distributive. We can see mathematically a dot b plus c is equal to, this is a vector, dot b vector plus c is equal to, this a vector is equally distributed with b and c. It means dot product is distributed with second and third vector. It means that a vector dot b vector plus vector a dot c vector. So this property is known as distributive property of dot product. Now we'll see last property of the scalar product or dot product, that is commutative property. It means that dot product is commutative. Mathematically we can say that vector a dot vector b is equal to vector b dot vector a. So we have studied 5 properties of the scalar product or dot product. We can quickly revise. Scalar product is commutative, scalar product is distributive, scalar product or dot product of two equal vectors is equal to the square of its magnitude. The scalar product of two collinear vectors is positive or negative, and two mutually perpendicular vectors, the dot product of two mutually perpendicular vectors is 0. So that's all about the scalar product and its properties. Thank you.